Hey kids, this is Mr. Pickett. What we're going to talk about today is a little bit of a pathway of how we are going to kind of work through this week. And so I'm going to maybe kind of talk about what our plan is like today, and then we're going to shift to our lesson today. So one of the things that we're going to be doing is we're going to be talking specifically today about some components of a good lab. Right. And the purpose behind talking about the components of a good lab is because you guys on probably like Wednesday through probably next week, Wednesday, are going to be literally kind of designing and executing your lab. That's literally what we're gonna kind of go through and do. See if I can move this. Here we go. So, and my purpose behind this is to make sure that you guys have some critical thinking skills, showing you guys as well, like what, when you take a science class, we're going to have these components as well. But I want to move on from just having you guys read directions and executing a lab to actually thinking about how do I create my own, right? What does that process look like? And then once I own a lab and I create it myself, do I have the do I have the wherewithal to actually like finish it and then follow through and then like get the things out of it that I need? And so what I need to do today is to build your guys' understanding of what is a lab, like what's the purpose behind it. So number one, like why do we do labs? Right. I think that there's a lot of potential answers to this question, but a lot of them kind of fall short. Sometimes it's a time filler for your science classes. Sometimes it's for the teacher to have you like get to a specific end. But really, like, why do labs exist for any scientist is because they are curious and want to answer a question. That's why. And usually it's something that we see in nature and we're trying to solve some sort of a problem as to why something is occurring, or trying to make an understanding about some phenomena that we see in the natural world. So that's like an overview of like, why do labs exist? And then, the lab itself is, we have the why. And then what we want to do is we want to do the lab to get some sort of an evidence. So that evidence can do a couple of things. What it can do is it can, prove that you're right. Your original thought as to why something is occurring, it's proved right based off of the lab that you did. Or it can do the opposite of that. It can say, you know what you thought was absolutely incorrect. Here is the actual line of thinking that you need to follow. Or what can happen, and this is the lot of case, what happens in like real life, is that the answer to the question you initially had leads you to another question because you're not quite there yet. And so you collect evidence to try to get a little bit closer to your curiosity, the question that you initially had. And so, and again, that evidence is going to point you in some direction. So let's kind of change this and let's talk about what are some good components that exist in labs that exist across the world. All right. So number one, in a lab, you need to make sure you have some sort of a title. And the title, pretty simple. It describes what you are doing in your lab. And a good title is concise, meaning that there's not a lot of words, and it does a great job of describing exactly what's happening. Now, for me, when I think about a title, I think about a book title. And a book title sometimes does not tell me exactly what I'm going to read. It might eventually give me some clues. It might pull me in and intrigue me. But in the science world, the title is really pretty cut and dry. It describes what lab that you're doing. What are you trying to solve to a point? What is your lab about? So then the next thing, which I find to be probably the most important thing that's on here, is that you have your purpose that's stated, or you have the question that you want solved. So you have a reason why the lab exists. Like you have that initial question, it might be, why is the sky blue? That could literally be your purpose. You're trying to drive and figure out the answer to that question. So you have to state a question, or state your purpose, or you have to basically write down what question you're really trying to get after. Right. And you can't really go any further than here. Like you can't start adding other things in here unless you get to this point. All right. Now, number three, right, after you've stated your purpose or you have a question that you want solved, you have to provide a hypothesis. Now, a hypothesis is different than a prediction. And I'll use my family as a good example of what's the difference between those two. So last night at the dinner table, my son predicted when there was going to be snow that was actually on the ground. And so he did that by just saying this Thursday, there's going to be snow on the ground. Now, he wants his prediction to be correct because he gets to choose the evening activity if he's the closest guess to when the actual snow falls on the ground that stays for 24 hours. My wife and I think, made more like a hypothesis. And so what is a hypothesis? Well, it is a prediction. It's a guess. However, a hypothesis is beefier than that. It's based off of background experience. My wife and I are 36 years old. We have almost 30 more years on this planet than my son does. And so I think we have a better understanding about probably when it's going to snow. And also, we've both done research. My wife and I both look at the weather significantly, and that matters to us. And so my hypothesis was the 20th, and my wife's hypothesis was the 24th. So as students, and I was making a little bit of a joke to our freshman boys in particular, we tend to make predictions. You know, you as a freshman class, you guys are young, you don't have a lot of background experience, but if you just do a quick, like, this is what I think, that is more of a prediction. But I want it to be more than that. A hypothesis is where you've done a little bit of research, especially if you're not an expert, or at least you have some expert knowledge in that area. And so do some research in order to make a stronger prediction, otherwise known as a hypothesis. Now, your hypothesis needs to be testable. Again, why is the sky blue? That becomes kind of a difficult thing to test, but I can test, I think the sky is blue due to bunny rabbits existing. I can make a connection and I can find that. I don't want to make such an open-ended question that can't be really tested and have a really good answer to. So a good hypothesis in the science world can be tested. It can be proven right or it can be proven wrong, right? So it has to be testable in some way, shape, or form. Number 4, after we test a hypothesis, or excuse me, when we have a hypothesis, the whole purpose of your lab is then to test, right? To actually go through and prove if that prediction or that hypothesis is right or wrong. And so you need to collect evidence or collect data, right? Your evidence that exists. So once we get to this point, generally kids in my previous years do 1, 2, and 3, and then they just start on their lab and they don't have any like clear plan. They just start, and that's silly. You know what evidence you need to collect. Like in my snow example, right? I could literally write down, and I'd probably write something down like this. I'd have a data table which would say, you know, the 17th. Actually, we're what day of the week? It's the 28th right now of November. Right? And then it's either going to be snow or no snow. So I'd leave a blank. And then I would have November 29th and I'd leave a blank. I'm trying to think about the days of the calendar, and here we go to the 30th here. And I'd keep going down, and I'd have part of this data table filled out because I know what I'm changing. And I know how I'm making adjustments within this activity. And I know that I'm collecting a piece of data. Like today, it's the 28th, there's no snow. So no snow, easy. And then I'd just write down 0, right? There's 0 snow. And I would keep going down until I get some sort of a piece of data, or I would collect this for as long as I need to. So you have this data that exists. The reason your lab exists is to collect this data. And then what we want to do with this data is we tend to want to make it visual. And so we need to make that data into some sort of a graph or graphs. And that's a visual representation of the data that you collected. For our intents and purposes, I would expect by this Friday that you guys would have graphs based off of the labs that you guys are conducting. And so this is roughly where we'll probably stop really like focusing on this week. But we are also going to cover number 5 and number 6. And number 5 is being able to analyze your graphs / data. And then number 6, the pretty important question on here is that you're going to get to your conclusion, which your conclusion's main job is to ask the question, right? Did the data support or refute your hypothesis? That's really what its job is. There's other pieces to this, but that's the general idea about a lab. So what we're going to focus on before we like get to Wednesday is we're going to probably focus on 1 through, probably 3, right? 1 through 3 are going to be important things for us to kind of get after. And then I'm going to help you guys kind of narrow the focus in terms of what we're going to be testing, what we're going to try to find the answer to. So that way it's not so broad and overwhelming for everybody. All right, awesome. Hopefully this is going to help you guys. I don't know how much time is going to be left in the period, but use this as a study all, and have a great rest of your Monday. Bye, kids.